Hello again. So, if you're doing this right, this is the second video you're going to watch related to blood typing if you missed the stuff that we did in class this week. And again, I felt like it was worth taking a deep dive into blood typing because it's relevant, it's interesting, and the knowledge that you gain right now could literally save your life. So, without further ado, I've pulled up one of the simulations that I actually had you work on in the blood analysis lab last week. This is one that I didn't have you do, but I felt like it was worth going through to kind of get you some background into what blood typing looks like, what we would do if we actually did this test in the lab. We've actually done this in previous classes where we had the nurse come in and she would have us prick our fingers, put 3 drops of blood on a microscope slide, and then we would test them using the antibodies that you see on the screen here. So just to give you an idea of the setup, we have 3 bottles, and these 3 bottles have antibodies. The serum contains antibodies against the A antigen, the B antigen, and then the Rh antigen. And then we have 6 samples of blood. I'm going to go through 3 just to give you an idea of what we're up against here and to explain what the tests actually mean. So what we're looking for here is something called agglutination. If the blood samples that we're going to test have the antibody present, then we're going to see clumping. And it's almost going to look like tiny little grains of rice in the blood sample. If that blood does not contain that antigen, then the antibodies won't react and we'll just see basically watered down blood. And you'll see what I mean in a few minutes. So the way we're going to do this is we're gonna follow the directions here, and we're gonna drag this slide. You notice that slide has a couple little depressions here, and the first thing we're gonna do is we're going to put some blood from sample 1 into these 3 bottles, into these 3 wells rather. Now, what we're gonna do now is we're gonna take the anti-A antibodies and put a drop in the A well. We're gonna put anti-B antibodies into the second well, and then anti-Rh antibodies, hopefully, into the third well. So now we've got our antibodies dropped in, and we want to mix them up. We want to make sure we mix them together so we get a good reaction. And we're going to mix them with separate stirring sticks here. In the lab, we use toothpicks typically. And we're going to dispose of all of them in the biohazard when we're done, because this is live blood that we're working with. So once we do that, now we are going to drag this slide over to this light. Typically in the lab, I would have you put this on a white sheet of paper so you'd be able to see it easily. And then we're going to see what the reaction is. So what we're looking at here are the 3 reactions that occur in the presence of anti-A, anti-B, and anti-Rh antibodies, respectively. So the anti-A, you can see that this has changed. It's not as though it's just watered down blood or antibodies mixed with blood. We've had a reaction here, and that reaction is called agglutination, this clumping that we see. If this occurs in your own blood, it's very dangerous. This blood that is clumped up tends to clot more easily. It doesn't carry oxygen as well, really at all. And it can be potentially fatal if you receive the wrong type of blood. That's why it's so important that that hospitals and medical facilities know the type of blood that you have, as well as the type of blood that is being donated. So this is a positive reaction for the A antigen. So this blood does contain the A antigen. If we go over to the anti-B space, we see that really it's just watered down blood. It's just antibodies mixed with blood and no reaction has occurred. So we would say that that's a negative reaction for the anti-B antibodies. With the anti-Rh antibodies, we see something similar to the first one. We see a clear liquid with a bunch of clumps of red blood cells in there. So that is another positive reaction. So we're going to go ahead and record that. We'll come back to what that means in a little bit, but I want to run through these next 2 samples real quick. So we're going to dispose of this properly in the biohazard. We're going to pull out a new slide. And actually, if the patient's blood type is AB negative, what would be the appearance of the A, B, and Rh samples? This is a question that I need to answer before I can move on. So, if it's A, that means that it does have the A antigen. So we would see a reaction. We would see clumping here. If it's AB, that means it has both the A and the B antigens. So we would see clumping with both the anti-A and the anti-B antibodies. And finally, if it's negative, that means it doesn't have the Rh antigen. So the Rh antigen would remain unclumped. It would just mix up with the blood. So this will be the correct answer. It's not going to tell me if it's correct, but trust me, it's correct. So now I'm going to do the same thing with the next two samples. It's going to do this automatically for me, so I'm just going to kind of let this run for a moment. And again, what we're looking for in each well is this process of agglutination, of clumping. And if clumping does occur, we know that that blood contains that particular antigen, whether it be the A, the B, or the Rh. Now, if we saw clumping in all three of these wells, it would be A, B positive. If we saw no clumping at all, we would see O negative. I happen to have type O negative blood, so if I were to do this as a demonstration in class, it would be very boring because I wouldn't elicit a reaction in any of those wells. So let's see what we got here with sample 2. It looks like there's nothing happening with anti-A, again, just blood mixed with antibodies, so that's a negative. Definitely a reaction with the anti-B. That looks very different from the previous sample, so that's positive. And we can see that the Rh reacted again. So we have the B and the Rh antigen in sample 2. Okay, so now we're going to do the same thing with sample 3. And it's going to kind of go through things automatically, and then in a minute we should see those test results pop up. And then we will see if we can translate these test results to what type of blood we actually have in these samples. Okay, so we have a positive test with the A antigen. We definitely have a positive test with the B antigen. But again, the anti-Rh just has watered down blood. The blood looks like it's pooled in the middle here, so that's a negative. Okay, so I'm going to go ahead and wrap up the testing part there in the interest of time, but let's break this down. So if we have agglutination with the anti-A serum, the anti-A antibodies, that means this blood does have the A antigen, so it's at least A. If we don't have agglutination with the anti-B, which is the case here, then we don't have the B antigen, so it won't be AB. And if we do have agglutination with the anti-Rh, that means we're positive. So this blood type in blood sample 1 would be A positive. Now, similarly, in sample 2, we don't have a reaction with A, so it's not A. We do have a reaction with B, so it is B, and it has the Rh antigen. So we see that this blood is type B positive. Not only a great blood type, but a great outlook on life. So in this last one, this is actually the very example that we had to answer in that question just now. We see that we have a reaction with A and B, so this is type AB blood, but because there's no reaction with the anti-Rh, that is AB negative. So I hope that this is helpful. I know that, we may not get to interact directly, but hopefully this will kind of simulate the experience that you'd have in class. And I'm going to wrap it up now, and I hope you have a great day. Thanks.